Let's talk subtraction. How comfortable do you feel with addition from yesterday? Feel pretty comfortable and strong? Because subtraction is just the same thing. You still need two pairs, but now from the givens to the proof, my angles or segments are getting smaller. That's the only difference. I'm getting smaller. So I want to do the same activity I did with you yesterday when I introduced addition. Here are my four segments. All right, A and B are congruent, C and D. Now give me pairs that I can subtract that would be congruent by subtraction now. Give me pairs, and remember, probably start with A or B, right? You don't want to start with C minus B, because I don't know how long that line segment would be. It'd be like a negative, and that can't happen. Johnny, you going to give me something? A minus C equals B minus D. Love it. There you go. Or somebody else now, honors kids, give me a new pair I could have also subtracted other than the one Gianna just gave me. 12. Let's go. Hello, Olivia. B minus C equals A minus D. Yep. And that is, and be careful here. Some kids confuse this with substitution because it sounds the same for some reason. All right. All right, ready to use it in a proof. How do I know it's a subtraction proof versus yesterday addition? That's my main concern right now. How do I know? All right, let's take a look at the givens you guys have. You have angle DAC congruent to ECA. Can you take a look at those two angles? What type of angles are they from Unit 1? What do we call those angles, DAC and ECA? Those are called straight angles, right? And how much do they measure? Anybody remember? 180. Okay. It's kind of tough to mark that. I guess you could put like a little arc on top and top if you want to mark it that way. That's your call. And also I have 1 congruent to 2. We can mark those though. All right, first let's talk, why is this subtraction? Why can't it be addition from yesterday? Again, tell me when DAC was how many degrees? 180, and now you're going from DAC to angle 3. Everyone can agree angle 3 is a heck of a lot smaller than 180 degrees, correct? So now am I getting smaller or bigger? I'm getting smaller, which means now instead of addition yesterday, I need to subtract if I want to get smaller. How many quantities do I need to subtract? 2. How many to provide? 2. So guess what? Statement 2 is going to be my subtraction statement. Everyone all right? I'm getting smaller, and everyone can see that in the diagram that I'm getting smaller. All right, name the angles you want to subtract now from the givens. Pair them up correctly. 15. Hi, Gabby. Let's start out with the straight angle. Angle. Yep. Angle 1, because that's the one on DAC, is the same as doing what, Gabby? Minus angle 2. And now we replace, just like we did with addition. Now we replace DAC minus angle 1. What angles are you replacing it with? 2. Zoe, what angles are you going to replace? Let's start DAC minus angle 1. I'm going to put in what for it? Angle 3. And then ECA minus angle 2. I'm going to plug in angle 4. Good. And that is substitution. Subtraction, questions. All right, one more subtraction just to make sure we're solid. Okay, so take a look at the given. DF congruent to BE. So somehow, appropriately mark that on your diagram. All right, so you know DF is, I do one way, I do, like brackets or something like this, just so we know what the congruent. You're welcome. It's already in your statements. And yep, you're welcome. All right. You have to decide. We know the answer is going to be subtraction, but tonight on homework, you're going to have to decide, because I snuck a couple additions on the homework. Which one is it? Look at the given. Take a given segment. Let's take DF. Look at a proof statement, DE. from DF to DE, is that segment getting smaller or bigger? Smaller. We can all see that, hopefully. That segment's getting smaller from the givens to the proof. So if it's getting smaller, I'm going to need to subtract. But how many quantities did I give you? Only one. You need two. So statement 2 cannot be subtraction. You're not ready. You can't. So now it's up to you guys. I'll call on somebody here in a second. Find what segment you need to subtract from DF and BE to get to DE and BF. What segment do I need to subtract from both of them? Probably because it's going to be the same angle or the same segment. 2, Zoe, back to you. Did you find that segment you want to subtract from both? Yeah. EF, darn right. Reflexive. Now you have 2. Now subtract for me. Tell me which segments you're subtracting from each other. 15. Gabby, back to you. Yep, equals. Good job. And now replace it for me. 13. Ksenia. Doing better. You correct me every time, and I feel like I still say the same thing, but you know it does to me. It does to me. Okay, DF minus EF. Replace it. There you go. DE, and what allowed you to do that? Yep. All right, so we're getting it now. We're getting it. It's just a matter of am I getting bigger or smaller? That's up to you guys. All right, so I'm going on to a totally different thing now. All right, we're done with subtraction, so I need to go to the last one today. Before I introduce that last one, just want to do a quick activity with you here. Up on the board here, I have 2 line segments, A and B, and I will let you know that they are the same length. They are congruent to each other. Here's what I'm going to do. I'm going to take line segment AB. I'm going to take half of it, and I'm going to give it to this group right here. All right, so I took half a line segment AB. This group now has it. Then I'm going to go to line segment B. I'm going to take half of it, and I'm going to give it to this group right here. What do you know about their 2 line segments? They're equal? Yes? Is that what everyone's saying, that they're equal? You're absolutely correct. Now the question is, why are they equal then? How do you know they're equal? Well, let's go back. What did I originally know about the original line segments? They're congruent. And I did what to each one? I cut them in half and gave to each. So you're telling me if 2 segments are equal, or maybe even 2 angles, if you cut them in half, the halves are also equal. Yes? Okay. Now I want to introduce to you our last theorem for today, which is called halves of equal quantities are equal. If you take half of 2 things that are equal, those halves will be equal. Before we do a proof, though, you are going to start seeing keywords in the givens that say, hey, it's time to use me in the proof. Forget about addition and subtraction. You got to use the new guy on the block. There's going to be 2 keywords I want you to look for, and you know them already. I'm going to give you 30 seconds in your group right now to remember 2 vocabulary terms from Unit 1 that say something is being cut in half. There's 2 vocabulary terms we talked about that said a segment or an angle is being cut in half. 30 seconds. Go ahead. And time. Any group confident in one of the words? Bisects. Bisects, yes. If I see the word bisector, here we go. Keywords, bisector. If that word pops up in the givens, I'm going to use halves of equal quantities are equal. Not addition, not subtraction. Halves of equal quantities are equal. Anybody? The other keyword I'm looking for? Zeeb, your group? Midpoint. Yes! If I see those words in the givens going forward for now, all right, for now, I know this new theorem is going to be somewhere in my proof, probably ending the proof. I wish it was that easy, that it would just be 2 steps and we're done, but take a look at this one I have right below. You have 2 segments, AB and DC. What do you know about them? What do you know about them? They're congruent, right? Just like the ones I just did earlier. What am I doing to one of them, AB, line segment AB? What am I doing to it? Cutting it in half, and I'm giving it a new name, which is AF. So, I cut it in half. Here's AF, group number 1. And then I'm taking the other line segment and doing what? Cutting it in half and calling it EC. So now what should I know about AF? I gave this group, and EC I gave this group. They should be congruent. Correct. Yep. So AF has to be now congruent to EC, not by addition, not by subtraction, not by substitution, by our new theorem, which says halves of equal quantities are equal. Because, again, let me review slower. You're taking half of 2 segments, which we already knew were equal. So their halves, whatever the new name we called them, has to be equal to each other. Okay, let's, this is our last one today because I want a lot of time for you guys to practice on your own or with other people in the group. The givens are in the statements, all right? The givens are statement number 1. I already put them in there for you. You're welcome. And we need to prove angle R congruent to angle S, everyone. All right, right off the bat, anybody see a key word that comes up? Okay, bisects. Get addition and subtraction, substitution out of your head. We're going to use halves of equal quantities. But this is not going to be a 2-step proof like the last one, and I will show you why. We are missing information here. All right, so I see bisects. It's going to be halves of equal quantities. Got it. Do I have a pair of equals that I'm going to cut in half? Do I have did I give you a pair of segments or angles that I'm going to be cutting in half? Yes, angle DCB and angle DAB. Mark them on your diagram. Angle DAB and angle DCB. All right, I got that part. What I didn't give you that you already had in the last proof is showing you're cutting them in half. I need to see that before you can use halves of equal quantities. You need to write down for me what's being cut in half and what you're calling it. Everyone, hey, remember these? See these from the last one? That's not in the givens. That's on you now. That's going to be statement number 2. Tell me what you're cutting it in half and what you're calling it. All right, so first, one angle I'm going to cut in half, according to the givens. 2, Zoe, one angle I'm cutting in half. Okay, ready? So half of angle DAB. Show me you're cutting that angle in half. Equal to, what am I going to call it now? Now, you can't call it anything you want. Got to look at the diagram. So everyone look at angle DAB. Everyone see that angle. If you cut that angle in half, you have 2 choices for a name. You can call it DAC, right? This angle right here, DAC, or you can call it angle R, which I've already placed there. You're right both ways, but I'm only concerned about one of those 2 angles in this proof. Am I concerned about DAC or angle R? Angle? Angle? One more time. Angle? What are you guys, pirates? All right. Anyway, set you up for that one. Good. I use that one every year. And we got that. Thomas, you got that one. Good. Favorite restaurant for a pirate? Come on, this is an easy one. I think they're going to get harder. We just did angle R, and I said, are you pirates? So now I'm asking for the restaurant. Wow. Do we just, do we know anything in society? Go out into the real world at all?
Arby's.
Thank you, Jack. Somebody, thank you. Arby's, good. Favorite country to go on vacation?
Argentina.
There we go. All right, we got it now. Favorite movie? anything rated. Anything rated R? No. Oh, you guys are off. Never mind. We're not going to joke around ever again. But yes, all right. I call it angle R. Good. Angle R. Woo! All right. This might be a rough year here. Now, that's not the only angle you're taking half of. Tell me the other angle we're taking half of so I can write it right below. 6. Thomas? We took half of DAB, and what other angle's getting bisected, being cut in half? DCB. So now I need to write half of DCB is equal to, now I need to give that a name. Look at DCB. Again, you have two choices. You can call it DCA, or you can call it angle S, which I have there. Which one do we care about? Angle S. And by the way, some of you, I should have went over this. Why am I concerned about R and S and not the other two? It's in the proof statement. Okay? In the proof. All right, now reason. You're not writing halves. That's the ender. Halves of equal quantities is to say R is congruent to S. How do you know you're taking half of that? What told us at the very beginning when you started reading your givens that, oh, I'm taking half of these angles? What alerted you to that? 5. Let's go, Haley. Definition of bisects. Perfect. Or bisector. It doesn't matter. So we have the congruent angles. I told you we're taking half of them. Now you can say those halves, which we called angle R and angle S, are now congruent to each other. And that is by not substitution, not addition, not subtraction. Halves of equal quantities are equal. Before I let you go on the assignment on your own, this, if I see midpoint, bisector, you know this is going to be used, but you cannot finish the proof until you have two things. The congruent pair, which will probably be given to you, and you're taking half of it. If you don't have this, you can't write this yet. All right? If I give all to you in the givens, sure, it's a two-step proof if it's all in the givens. But if those half statements aren't there, like they weren't for this one, you need to come up with them before you finish the proof with halves of equal quantities. All good. All right, a reminder too on the homework tonight, may have snuck in an addition one. Be careful, may have snuck one in. You play your cards right, you could be done with the entire homework before you leave.